The laws of exponents for integral exponents may be used in simplifying expressions with rational exponents, but we have to take note that in some real numbers raised to a rational exponent, such as the quantity of -1 raised to 1/2, are not real numbers, and in such cases, the laws of exponents do not hold. Now let us express c raised to 2/9 times c raised to 4/3 in its simplest form. Now, as we may observe, the variable c is raised to a rational number 2/9 and another rational number here 4/3. We may use the first law of exponent to simplify this rational expression. To do that, the exponent c raised to 2/9 times c raised to 4/3 will become equal to c raised to 2/9 plus 4/3, following the laws of exponents. Now we have to simplify the exponent, which is 2/9 plus 4/3. To do so, we have to take the LCD of the exponent, of the denominator of the exponents, and that is 18. 18 divided by 9 is equal to 2 times the numerator 2, that is 4, plus 18 divided by the denominator 3 is equal to 6 times the numerator 4 equals 24. Again, we have to simplify the exponent. 4 plus 24 is equal to 28 over 18. The exponent can still be expressed in its lowest term, and that is 14/9. So the simplest form of the expression c raised to 2/9 times c raised to 4/3 is c raised to 14/9. Express the quantity of x raised to 2/5 times y raised to 4/10 raised to 5 in its simplest form. So as we may observe in this example, we can apply the laws of exponents by multiplying the outer exponent -5 to the exponents inside the parentheses. Doing so, this expression would be equal to x raised to 5 times -5 times y raised to 4/10 times -5. Simplifying the exponents, this expression would be equal to, cancel this out, that would be equal to -2. Y, you may cancel this out to 1 and this to 2. So -4/2, and that is equal to -2. Now, having this expression x raised to -2, y raised to -2, we may use and apply the rule for negative exponents. The bases x and y has denominators 1, and we only have to take the reciprocal of the 2. So the reciprocal of x over 1 is 1 over x, and then take the exponent -2, change it to positive, times the reciprocal of y over 1, which is 1 over y, and then the reciprocal will be positive 2. Multiplying the two expressions, 1 times 1 is equal to 1, and x squared times y squared is equal to x squared y squared. And this will be our final answer. Express a raised to 1/2 divided by a raised to 3/10 in its simplest form. So to do that, we have again to apply the laws of exponents. So this expression will be equal to the base, and then the two exponents 1/2 and 3/10 have to be subtracted. So that would be 1/2 minus 3/10. And to simplify the exponent, we have to take the LCD of the 2, and the LCD is 10. 10 divided by the denominator 2 is equal to 5, times the numerator 1 gives us 5. minus 10 divided by 10, and that is equal to 1, times the numerator 3 is still 3. Simplifying this further, 5 minus 3 is equal to 2 over 10. And 2 over 10 in lowest terms is equal to 1 over 5. So the final answer is a raised to 1 over 5. Express the quotient of 2 raised to negative 4 over 3 and 2 raised to negative 5 over 6 in its simplest form. So to do that, we have to copy the base and then subtract the two exponents, negative 4 over 3 and negative 5 over 6. Doing so, we have to copy the base and then subtract the two exponents. And negative times negative becomes positive. Now to simplify the exponent, we have to take the LCD. And the LCD of 3 and 6 is 6. 6 divided by the denominator 3 is 2 times the numerator negative 4, that is negative 8, plus 6 divided by the denominator 6, and that is 1, times the numerator 5, gives us still 5. Simplifying this, negative 8 plus 5 gives us a sum of negative 3 over 6. And negative 3 over 6 can be expressed in its lowest term, negative 1/2. But since we still have a negative exponent, we have to express it using positive exponents. So to do that, we have to apply the rule for negative exponents. So the expression 2 raised to negative 1/2 will be equal to 1/2 raised to 1/2. Last example, express the quantity of x raised to 12, y raised to 0, raised to negative 1/2 in its simplest form. Now, observe that in the given expression, there is a variable raised to 0. So we can simplify this expression as the quantity of x raised to 12 times 1 raised to negative 1/2. And 1 times x raised to 12 is equal to x raised to 12 raised to negative 1/2. To simplify this, we only have to multiply the exponent outside the parentheses to the exponent inside the parentheses. So this expression would be equal to x raised to 12 times negative 1/2. We may cancel this out to 1 and this 1 to positive 6. So we have to get the product of 6 and negative 1, and that is x raised to negative 6. Since we have a negative exponent, we have to express it in positive exponent. So to do that, we have to use the negative exponent rule. The variable x, which is the base, has a denominator of 1. We have to get its reciprocal, and that is 1 over x. 1 over x, and then the exponent negative 6 becomes positive. So our final answer is 1 over x raised to 6.